with number 14. On this review 1.1 to 1.4, we'll start on problem 14, and then we'll crank through the end of the sheet. And then tomorrow, you will need to say to me, Mrs. Ford, I was looking at the sheet and I really need to do question 7, or I really need to do question 12, or something like that, okay? But we're going to start with number 14. What is the difference between a whole and a vertical asymptote? That's like an essay question. What is the difference between a whole and a vertical asymptote? How would you explain that? I mean, obviously we know what the physical difference is, the way they're graphed. But how is it different how they appear in the problem? Exactly. A whole is a removable discontinuity. It cancels out of the problem. An asymptote, a vertical asymptote, is a non-removable discontinuity. It does not cancel out of the problem. So they are both discontinuities, but the whole is less severe because the curve is actually going to be connected at that point, just an open dot. The asymptote completely breaks it. The asymptote breaks the picture completely into two pieces. All right, speaking of broken, let's look at number 15, which is a piecewise function. I promise you're going to have to sketch one of these on your text. So when you look at this, does it occur to you that the breaking apart into pieces is happening where x is -2? That's where the picture gets broken up into various pieces. All right, what does that top one look like? I'll do that top one with my green marker. What is that shape? X plus 1. That's a line. It's the identity moved up one. So that's supposed to be a nice straight line. There it is. But I don't want the whole thing, do I? Not in a piecewise function. I want a piece of it. So here's where it hits the line, right there. Will that dot be open or closed? Open. Open. And remember, your function tells you what to keep. So I'm keeping that, which means I'm keeping which side? Left. So I'm going to erase this. That's the break. That's -2. That's where it's broken. Now, I don't know if we've seen this before, especially if you're not looking at any of the problems in the book. This says y equals 5. But you only want y to equal 5 when x equals -2. What does that look like? It's a point. That's nothing but a point. That's the point where x is -2 and y is 5. Y equals 5 is the whole horizontal line, but you only want the place on the line where x is -2, which would just be that point. Right? That's it. One place. One x, one y. What's this look like? That's your parabola. Vertex at the origin. Now it crosses right here. That's where it breaks, right there, -2. Open or closed dot? Open. And I'm going to keep the right side, because that's where the arrow's pointed. Whoa, that's a freakish looking picture, but it's exactly what it should look like. Remember, your dots have to be lined up. You can't have more than one closed-in dot. This has to be a function. So one closed-in dot's all you can have, and you have one piece of the picture on the right, on the right, and one piece of the picture on the left. You'll never have two lefts or two rights. You can't. It's a function. Anybody have a question about that? All right, 16, given all these different things. Can you do this? Sam, we're on our review sheet, the sheet called Review 1.1 to 1.4. All right, anybody have a question about, or anybody know what I'm supposed to do with this first one? Here's P, here's Q. What does this mean? Atom, just atom. So wouldn't that be x squared plus 8x plus 1 if I put it in descending order? That's all. Don't solve that. Don't do the quadratic formula or something. No, 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 no. This is it. You're just adding them together. What's that mean? 2 in the Q. Put 2 in the Q. So Q of 2 is 16. And then take the 16 and put it into P. What is that? 257? 16 squared plus 1. Remember, we go backwards. So 2 in the Q, and then that answer into P. What about the next one? All right, so we're going to put 9 into P, so that'll be 82. And negative 4 into Q, so negative 32. And then the problem says add them together, so I guess the answer is 50. That's easy enough, right? Okay, now the little asterisks mean I need a calculator. So let's get our calculators out. Speaking of which, if your name's up there somewhere, you need to get your fine paid. All right, so I'm supposed to find the relative maximum of this curve. So first thing I'm going to do is zoom square, not zoom square, zoom standard, I'm sorry, zoom standard, because I don't know what window I should be using, so I'll just use a standard window to get started. And then I'm going to type in my new equation, which is 9x cubed minus 8x plus 5. Did you get a picture? This isn't the best window possible. It's kind of squished. But did you get a picture that looks kind of like this? Okay. Now, first of all, a connection maybe we haven't made before. This is an x cubed equation. X cubes, remember, are this squiggly. When you put that extra stuff in the problem, like the minus 8x, that causes that squiggly to get even squigglier. So there's a definite squiggle in that one, right? This is the point you want. That is called the relative maximum, or the local maximum. So do you remember how to find that? Second calc, go down to maximum. You want to be on the left, you want to be on the right, and we want to be on it. Did you get negative 0.544 comma 7.903. We aren't going to be close on that. We're going to match, right? We're going to match. There's one maximum point there. Everybody's going to find it. So if you didn't get that, you might want to stop by after school so we can make sure you know what you're doing. All right, and then number 18, we have to find the equation of the function that represents this data. All right, now, first of all, we're going to plot it so that we know whether it's linear or quadratic. So remember how to do that? We go to Stat, Edit, and we're going to put these numbers in. Now, if you try to plot this with a standard window, things aren't going to go well. Look at your X's and look at your Y's and adjust your window. Your X's should go from about 0 to 8 maybe, and your Y's should go from about -5 to 55, something like that. What's the last thing I have to remember to do? Turn my plot on. Yep, if your plot's not on, you're not going to get any points, folks. Got to have your plot on. You want to plot points. What did you come up with? Did it come up looking like a line, or did it come up looking like a parabola? Parabola. So that tells you you have quadratic regression. So you'll go back to Stat, over to Calc, and down to quadratic regression. Make sure you hit quadratic regression, QUAD. My equation, because this says write the equation. This would be y equals 2x squared minus 3x. Now I'm putting my calculator down, in the back of my mind, my stat plot's still on. So when I have trouble graphing something later on, I'll know it's because I got to turn my plot off. All right, that finishes that sheet. You want to take a look at the rest of the front there? Or the next sheet, which says extra practice, or extra review. I don't really care what we look at. Is there anything for anybody, anything that looks like you have, you're not sure about it? Well, find the range of the function. Now, range for me, personally, is easier to find if I have a sketch in front of me. It's not required, but it's easier. So I know, in number 12, I know what that looks like. What does number 12 look like? A V. But the V has gone right 2 and up 1. So the V looks like this. So what's my range? Greater than 1, greater than or equal to 1. That would be my range. If we had to say if that were bounded or not, we would say, yep, it's bounded below, right here. Anybody else see something that looks worrisome or fascinating? What? Number 1, find the implicit functions. those are the answers. You're looking at the answers. They're all worked out. Yeah, you have a page of the problems, and then you have a page of answers, and then you have some more problems. Right? Nobody sees anything else on that sheet that you're not sure about? What about the extra review page, the last page of the little packet? Anything there? I'll tell you one I got to look at is number 2. Number 2 says, I know that f of 4 is negative 2, and f of 4 is negative 2, and f of negative 4 is also negative 2. I don't have an equation. All I have are 2 function values, which, by the way, represent ordered pairs. This is the point x, y, for negative 2. F of x, that's your x value. So you have that point and you have this point. Let's look at those 2 points. 4, negative 2, and negative 4, negative 2. Look at those 2 points. Even, odd, or neither. Even. Why do I know that? Just by looking at them. They're symmetric across the y-axis. And if you're symmetric across the y-axis, you're even. Now, what's the test for symmetry? Change the sign on x and nothing changes. Well, look what happens, kids. When we went from 4 to negative 4, did it impact the answer at all? No. Obviously, it's even. If you can change the sign on x and it doesn't change your answer, then you're even. What would happen if it were odd? Let's say f of 4 is negative 2. If I change this to negative 4, what would happen to that 2? It would become positive. Because if you're odd, you're symmetric about the origin. And what is the test for symmetry with the origin? You change both sides. Right? So if x changes, y changes. All right, well, that was fun. Enlightening. Monica, don't you wish you could stay?